This is section 1.4. We're going to be rewriting formulas and equations. That's going to be our main goal for this section. Some vocabulary. A formula is an equation that relates two or more quantities, usually represented by variables. To solve for a variable, we rewrite an equation as an equivalent equation in which the variable is on one side by itself and does not appear on the other side. Here are some common formulas that we have worked with in math classes years past. The distance formula is distance equals rate times time. Temperature in Fahrenheit is 9/5 Celsius, that's what C stands for, plus 32. The area of a triangle, that is area equals 1/2 and then times the base times the height. The area of a rectangle, I'm going to change this one a little bit. The area of a rectangle is area equals length times width. And the perimeter of a rectangle, I'm going to change this one too a little bit. So the perimeter of a rectangle, that's just 2 times the length plus 2 times the width. The area of the trapezoid, that is the area equals 1/2. Then I'm going to add both of my bases together. That's what B1 and B2 mean. Then I'm going to multiply that times the height, h. The area of a circle, that's just pi r squared. And then that last one, the circumference of a circle, that's 2 pi r, or 2 times pi times the radius, or just pi times d, or pi times diameter. You've probably seen these either in geometry last year or in other math classes as you've grown up. So, for example, let's try to find a formula or rewrite a formula using these two variables. So we have that Fahrenheit temperature formula, and we want to solve for C, or Celsius. So that's the first thing we need to do. So let me go ahead and just rewrite the temperature formula. And again, we want to solve for C. So right now, let me get rid of the 32 by subtracting. I can't combine Fahrenheit and the minus 32 because they're not the same number. They're not like terms. So I'm just going to leave it alone. So F minus 32 equals 9/5 C. But here's where we get into the dilemma again. What we're going to do is multiply by the reciprocal of 9/5, like we did and talked about in section 1. So the reciprocal, again, you just flip the fraction around. So we're going to multiply the reciprocal, or 5/9, on both sides, so that these will actually go away, these fractions. And you're going to be left with that Celsius, which is what we wanted, and 5/9 and Fahrenheit minus 32. That's what we solved for Celsius. Then it says in the second part of it, okay, find the temperature in Celsius if the temperature is 75 degrees Fahrenheit. So I'm going to use that formula we rewrote. Okay. And they tell me, well, Fahrenheit, I could plug that in for F. That was 75 degrees. And according to PEMDAS, I need to do my parentheses first. So I need to do 75 minus 32. That is 43. And the last thing I need to do is take 5/9 times 43. And that's 215 divided by 9. But that's really 23.8 repeating Celsius, or degrees Celsius. So there would be the same temperature in Celsius as 75 degrees Fahrenheit. In example 2, we're going to rewrite another formula. In this case, this is the area of the triangle formula. Area equals 1/2 base times height. But we want to solve it this time for the height. So again, let me rewrite this formula. And we're going to solve for the height. So, like we did again in section 1 in that first example, I got a fraction. So I'm going to multiply it by the reciprocal. Okay. Well, 2/1, that's just 2. So that's like saying on the left-hand side, 2 times area is base times the height. And I'm solving for h, so that last part we need to do is just divide by b, so that the b's go away, and I'm left with h equals 2 times area over the base. So that's our rewritten formula for h. So that satisfies the first part. But now we need to find the height, or the h, okay, of the triangle that has a base of 6 inches and an area of 27 square inches. So I'm finding the height. So I'm going to rewrite my formula again. They tell me, well, the area is 27 square inches and the base is 6 inches. So I need 2 times 27. That is 54. And I'm dividing that by 6 inches. Well, 54 divided by 6, that's 9, and we're working in inches. So my height equals 9 inches. So my triangle is 9 inches tall. In example 3, this is our linear equation. So now we're going to try to solve for y. So an actual variable that we see a lot of times is x or y. Well, in this case, it's y. So let me rewrite my linear equation here. And I'm solving for y. So let's see, I need to get that 4x term on the other side, so I'm going to subtract it. So I'm left with negative 3y equals, well, 12 and negative 4x, they're not like terms. I can't do anything with them or combine them, so I'm just going to leave them alone. So negative 4x, and I had a positive 12, so plus 12. So I need to get rid of that negative 3 with that y, because I need just y. Well, right now they're being multiplied together, so I need to just divide by negative 3 so that they cancel out. So y should equal negative 4x plus 12 over negative 3. So here's my rewritten linear equation for y. Then the second part says, well, I need to find the value of y when x is 6. So let me rewrite that formula again for y. They told me x is 6. Let me plug that in for x. Okay, so negative 4 times 6 is negative 24. Plus 12 over negative 3. Well, negative 4 plus 12 is still negative 12 divided by negative 3. That is positive 4. So y equals positive 4. And again, you can go back up and check that too if you really wanted to make sure that you were correct. So if I check this, x was 6 and y we found to be 4, and that should be 12. Well, 4 times 6 is 24. Negative 3 times 4 is negative 12. Should equal 12. Well, 24 minus 12 is 12, which again still equals 12. So that is good, and y is really 4. In example 4, this one's going to look a little bit different. Okay, so this tells me I need to solve for y again. So let me rewrite it. 3y minus xy equals 7. So this one's a little weird because I got two variables going on in x, y, and I want to solve for y. But what I'm going to do is pull a y out from both of them. So I'm going to pull that y out. Okay. And it makes sense because if I were to distribute that y back into them, it would give me back 3y minus xy. So all I did was pull it out. So this tells me y times the quantity 3 minus x equals 7. But if I want y all by itself, I can divide by quantity 3 minus x just to get y. So here's going to be our rewritten equation here. 7 over quantity 3 minus x. Then part 2 tells me again, well, okay, plug 5 in x for me. So if I rewrite it again, my rewritten equation, I'm plugging in 5 for x, and 3 minus 5 is negative 2, so I got y equals 7 over negative 2, which is really negative 3.5. Again, you could plug that back into y and get that x plugged back in there too, and it should check out to get 7. And the last example we have in this section is a multi-step problem. So a video game rental stores rents new video games for $6 and old video games for $4. So number 1, our first part, write an equation that represents the store's monthly revenue. So I am going to represent R for the revenue, or the amount of money they're going to make in the store. And, well, they have new video games, I'm just going to call N, and they were $6 a piece. So 6N for $6 for every new video game. Then I got to add on the old video games, and they were $4 a piece. But I'm not going to represent old video games as a variable of O because it kind of confuses it with 0. So I'm just going to call it maybe X. Okay, so I'm going to call it 4X for X representing old video games. So here's my revenue equation. So that satisfies the first part. The second part wants to know, okay, solve the revenue equation for the variable representing the number of new video games. We called that N, if you remember. So I'm solving this revenue equation for N. Well, I got to get rid of that 4x again. My revenue and negative 4x, they don't have anything in common. They're not like terms. So I'm just going to leave them alone. And I still got 6N. I just want plain old N. So again, they're being multiplied together. To undo that, I need to divide by 6. So I get that N equals revenue minus 4X over 6. So that's my equation for new video games. That satisfies part 2. Part 3. Okay. Well, the owner wants $11,000 in revenue. That's my R. So let me plug that in for R. 11,000. How many new video games, so that was N, must be rented if the number of old video games is 600? So that was our X, if you remember, for old video games. So let me plug that in my equation. So minus 4 times 600 all over 6. So I could figure that out. So first thing, I need to figure out, okay, 4 times 600. What's that going to be? Well, that's going to be 2,400 or 2,400. Again, all over 6. Now I need 11,000 minus 2,400. Well, that's 8,600 divided by 6. And when you divide that out, you get 1,433.3 repeating. But we're working in video games, right? And we can't really have 0.3 repeating of a video game. So what I'm going to do to get the revenue that they need more than 1,433 video games. So they need at least 1,434 new games. So we're working in new games. If I just had 1,433, they might not have met that $11,000 in revenue. So that's why I needed to round up and not down.